The Kardashev scale is a heuristic classification system that was originally formulated to quantify the technological advancement of hypothetical extraterrestrial civilizations by measuring their capacity to harness and use energy. Proposed in 1964 by the Soviet astrophysicist Nikolai Kardashev, the scale in its original and simplest form delineated three discrete types: Type I, Type II, and Type E, each associated with progressively larger reservoirs of energy, planetary, stellar, and galactic, respectively. At its core, the scale rests on a few basic premises: that the capacity to do work, generate observable waste, heat, or other signatures, and thus to affect one's environment at ever larger spatial scales, is both a meaningful and measurable proxy for technological advancement, that energy consumption grows or is at least redirected as civilizations develop more complex infrastructures and goals, and that by extrapolating from humanity's observed energy trajectory, one can create a framework useful for SETI, search for extraterrestrial intelligence, and speculative futurism. A Type I civilization, by common restatement of Kardashev's formulation and later refinements, is one that is capable of harnessing most or all of the incident stellar energy upon its home planet, whether by direct capture of sunlight, planetary scale engineering of climate and geology, or by storage and distribution systems that render planetary resources globally accessible. Put numerically in various expositions, this corresponds roughly to 1016-1017 watts of continuous power usage, though exact numbers vary by author and whether one uses instantaneous power or integrated energy per unit time. Carl Sagan, for example, proposed a logarithmic interpolation that maps actual power usage to a continuous variable k via k equals log 10 W610, where W is the power in watts. This allows for fractional types such as type 0.7 for contemporary humanity, and provides a framework for calculating how far a civilization is along the continuum between integer types. Other thinkers extended the scale upward. Michio Kaku and others proposed Type 4 or higher civilizations capable of harnessing energy on the scale of a universe or multiple universes, or harnessing extragalactic sources and dark energy. John D. Barrow suggested an orthogonal or minus scale concerned with the manipulation of small scales, atomic, nuclear, and quantum, and proposed stages that culminate in the modification of spacetime itself. Zoltan Galtai proposed resilience-based classifications attentive to a civilization's capacity to survive catastrophes of various scales rather than merely energy throughput. These extensions invite a key conceptual observation. The original Kardashev scale is fundamentally about resources and observable energetic output, and when one extrapolates beyond Type 3, the notion of energy available for consumption becomes ambiguous. Because advanced systems may not expend energy in ways that are thermodynamically or observationally obvious to external observers, they may compress computation into reversible or near-reversible processes, or may transition to substrates and modalities, for instance, gravitational or vacuum energy manipulation, that evade simple wattage accounting. From a physical perspective, there are multiple axes along which to generalize the concept: energy harnessing, information processing capacity bits per second, and storage, matter rearrangement and engineering, control over boundary conditions of physical law, and the capacity to initiate causally independent spatio-temporal regions such as baby universes, the possibility that the physical constants themselves. A Type 2 civilization expands the scope of control and engineering to the stellar system itself, constructing megastructures such as Dyson spheres or swarms, stellar engines, or other star-encompassing apparatuses that allow it to intercept essentially the entire luminosity of its host star and rechannel it for computation, propulsion, manufacturing, or other ends. Typical numerical prescriptions for Type 2 are on the order of 1026 watts. A Type 3 civilization, by contrast, is often described as having access to energy on the scale of an entire galaxy, capturing the aggregate output of roughly 10-11 stars, utilizing black holes as energy or information processing devices, and reshaping large-scale astrophysical structures for its purposes. The energetic magnitude here is sometimes given as approximately 1036-1037 watts. The original threefold division was deliberately coarse and designed as a practical guide for observational strategies. Kardashev's intention was not to prescribe metaphysical attributes to civilizations, but to provide an energy-based taxonomy that could translate into observational signatures. For instance, one could detect large infrared excesses associated with waste heat from megastructures or artificially modulated emission lines that might indicate intentional energy use. Over the subsequent decades, a very large body of literature accumulated around the scale, much of it speculative, exploring how civilizations might evolve beyond planetary constraints. Several refinements and extensions were proposed to make the taxonomy more continuous, multidimensional, and reflective of modern physical understandings, considering not just energy use, but also computation, matter manipulation, and control over spacetime itself. These reinterpretations transformed the Kardashev scale from a simple energy metric into a broad conceptual framework for cosmic evolution. The speculative notion of a Type 7 civilization or entity typically leaps over many intermediary conceptual steps to posit a being or system that no longer functions as a bounded civilization, but rather as an ontologically different entity. Not merely an agent that uses vast quantities of power, but one that can instantiate, modify, and destroy whole universes. Such a being could change the meta-laws that govern physics and exist in states that are causally disconnected or ontologically prior to our familiar spacetime. In such accounts, the word energy loses its operational meaning because the capacity to affect reality is not mediated through energy exchange, but through the alteration of the meta-variables that define the system itself. From a technical standpoint, several speculative pathways have been proposed for realizing such entities: mastery of quantum gravity enabling causal engineering, control over vacuum energy for universe creation, manipulation of string-theoretic moduli to select compactifications, and computational emulation of entire universes in substrate-independent systems. Each path implies unique observational consequences and costs. Engineering a vacuum transition could cause catastrophic energy release detectable as gamma-ray bursts, while simulations in low-entropy substrates might remain invisible because waste is confined inside the simulation's boundaries, rendering the process indetectable to external measurement. Thermodynamics and information theory still impose constraints even on these speculative scales. Landauer's principle TI's information erasure to energy cost, and reversible computation only minimizes, not removes, such costs. The Margolis-Levitin theorem and Bekenstein bounds limit the maximum processing capacity of finite mass energy systems. As systems scale up to cosmological levels, black hole thermodynamics and the holographic principle provide further ceilings on information density, suggesting that even ultimate computational civilizations must deal with entropy, horizons, and finite distinguishable states within causal regions of their respective universes or created domains. These physical ceilings imply that absolute omnipotence cannot exist within known physical laws, unless new meta-laws or causal domains are created. This is the conceptual hinge of Type 7 speculation. An intelligence that creates new causal domains with their own rules becomes a creator, whose constraints are detached from its parent universe. Detectability becomes nearly impossible at this level. Kardashev's original SETI-inspired metrics infrared excesses or megastructure signals fail if activity is energy efficient, non-electromagnetic, or confined to sealed regions. A Type 7 might remain unobservable by design or by moral principles preventing interference with lower civilizations. Sociological and ethical considerations emerge too. Moving from planetary to stellar and galactic engineering implies vast reorganizations of society and value systems, coordination challenges, Resource scarcity and feedback risks create pressures that might favor distributed, resilient, self-replicating systems over centralized civilizations. Even reaching Type 2 would require global political and cultural unity, overcoming existential risks, and preventing collapse long enough to construct Dyson swarms. These transitions involve not only technological feats, but also profound questions about cooperation, sustainability, and moral responsibility at planetary scales. Speculatively, identity and continuity pose new questions. If biological beings evolve into digital or quantum minds, or merge into a planetary superintelligence, what remains of individuality? Would such transitions be reversible, or would identity dissolve entirely into the collective substrate of a post-biological civilization? Methodologically, defining harnessing energy is crucial. But does it mean continuous capture, intermittent use, or reconfiguration on demand? Similarly, differentiating between computational and stored energy affects scaling estimates. Different assumptions yield drastically varied timelines toward higher Kardashev types. Attempts to quantify these timelines, whether Kardashev's linear extrapolations or Sagan and Kaku's refinements, depend on assumptions about growth rates, efficiency, and stability. Thus, while the scale serves as a conceptual map, it is not a predictive scientific theory, but a framework for discussing magnitudes of civilizational agency. In practice, research splits into two branches: observational SETI, which looks for technosignatures like waste heat, and theoretical work exploring computation, physics, and philosophy of posthuman futures. Both face deep uncertainty, yet both advance our understanding of civilization's long-term potential and cosmic role. Finally, speaking of a Type 7 human mixes metaphysics with science. If taken literally, it suggests a human attaining godlike power, raising issues of embodiment and cognition. If metaphorical, it symbolizes a civilization indistinguishable from divinity through its mastery of causal creation and universal manipulation. Either way, extrapolating beyond observation forces us into philosophy. Questions about ontology, identity, and epistemic limits replace physics alone. But the Kardashev scale remains valuable precisely because it keeps speculation grounded in energetics and systems logic, balancing imagination with scientific discipline. A Type 7 civilization, the ultimate on the Kardashev scale, would control energy on the scale of the entire metaverse around 10 watts. Such beings would transcend physical limits, manipulating all universes, dimensions, and even the laws of physics themselves. They could create or erase realities, control time, matter, and energy across infinite multiverses, and exist as godlike entities beyond comprehension, more concept than life, embodying absolute creation and destruction. What do you think of this powerful kind of humans? Can they easily defeat a character classified as boundless or not? Let me know in the comments.